I'm going to be talking about the brain-immune connection, the balance within. That's the science of the mind-body connection. I'll start by asking you this question. How many of you believe that stress can make you sick? Very enthusiastic, 100%. When I first had the courage to ask this question about 1995 to an audience of physicians and scientists, about a third of the audience put up their hands very gingerly and then put their hands behind their backs so their colleagues wouldn't notice that they believed in such a fringy notion. I am happy to report that, in fact, through the language of science, we have come now to understand and not only believe that stress can make you sick, we, the physicians and scientists, but how that works. And we're even at the point of understanding how salubrious activities, such as meditation, prayer, belief, can make you well. So that's what I'm going to focus on in this 20 minutes. We know that there is a rich network of ways in which the brain and the immune system talk to each other. The brain sends signals to the immune system, and the immune system sends signals back. I'm going to focus mostly on how the brain affects the immune system through the brain's hormonal stress response and neuronal stress response. So what happens when you're stressed is you pump out stress hormones from what's called the hypothalamic pituitary adrenal axis. That results in cortisol being released, and that suppresses your immune system's ability to fight disease. There's also communications through a nerve that we call the vagus nerve that regulates what we call the relaxation response, and there's communications through the adrenaline-like part of the nervous system. And there's also nerves that course through all parts of your body, the peripheral nervous system, that go to sites of inflammation that help you feel pain, and those nerve chemicals also change how the immune system functions. But to understand how stress can affect the immune system, first of all, we have to understand what stress is. So how many of you believe that there's such a thing as stress? Again, 100%. Preaching to the choir here. Okay, stress has many parts. This is the front page of the New York Times from the day in October a couple of years ago when all the stock markets were falling, except the ones in Australia, I gather. You're very fortunate here. You were quite protected. You notice that there are pictures of faces of stock traders around the world, Asia, Europe, the Americas, and you know that these people are stressed. The reason you know they're stressed is you are watching their physiological stress response. You know that they feel sweaty, you know they feel anxious, you know that their heart is beating fast, you know they want to run to the bathroom. These are all aspects of the physiological stress response. With permission, I'll read you a brief paragraph from my book, Healing Spaces. The chapter is called Mazes and Labyrinths, and the reason I'm going to read this to you is because I had the privilege when I was in Melbourne of being at Ormond College at the University of Melbourne, and when I walked into High Table and the students were wearing their black robes and the faculty walked through like Moses walking between the water parting, I sat at High Table and I looked out over this sea of young people, and I was very disappointed that they weren't flying about and casting spells, because I felt like I was in Harry Potter. So I'll just read this to you. When Harry Potter enters the maze during the Triwizard Tournament in the Goblet of Fire, his nerves, his self-confidence, and his senses are immediately put under enormous strain. The towering hedges cast black shadows across the path. They were so tall and thick that the sound of the surrounding crowd was silenced. We understand how he feels. He feels anxious. He feels sweaty. We understand how he feels because we have all experienced this stress response. This is a perfect example of the stress response, although we've never been in an enchanted maze, because we've all felt stress ourselves. We react to a stressful event, an initiating event, the bad thing that happens. In this case, and then the picture from the New York Times, it was all the stock markets falling. There has to be something very important that happens between the bad thing that happens, that initiating event, and that physiological stress response, and that's perception. If these stock traders had all their money in gold bullion under their mattresses, they would not be feeling stressed. So you have to have perception in order to have a reaction to that initiating event. You can't do anything about bad things that happen. That's life. You can't do a whole lot, although I'll show you now that you can do some things about your physiological stress response. But what you can really change is that perception in the middle, like the meat in the sandwich. If that response goes on too long, that's when you get sick. That's when it has an effect. So in order to understand how stress can make you sick, you have to understand something about the way the stress response works. So stress and your stress response is determined by dose, the dose of that stressor, the pattern of the stressor, the duration of that stressor, and gender. The fight or flight response, which is the typical stress response, was described 100 years ago by Walter B. Cannon in males, in male animals and male humans. Shelley Taylor at the University of California, Los Angeles, has coined the word tend and befriend, because whether you're a fruit fly or a mouse, a cat, a rat, a human, females have a different stress response than males. We don't have, it's not that we don't have a fight or flight response, but we do tend, take care of, and socialize. And that helps buffer the stress response. What about dose of stress? A single stressful event is unlikely to make you sick. Multiple stressful events where there's time to recover are also unlikely to make you sick. It's multiple stressful events that come fast upon each other, or chronic stress, that will make you sick. Chronic stress, such as chronic caregivers of Alzheimer's patients. These are the kinds of conditions that have been studied. And what happens is, during those periods, you are releasing a lot of those stress hormones and nerve chemicals that tune down your immune system's ability to fight disease. So when you're stressed, you're pumping out the brain's stress hormone, CRH, corticotropin-releasing hormone, from the brain's stress center, the hypothalamus. That makes your pituitary gland pump out ACTH, another hormone, and that goes to your adrenal glands that sit on top of your kidneys, and that makes your adrenals pump out cortisol. If any of you have used cortisone cream for a poison ivy rash or cortisone nose spray for rhinitis or allergic asthma, you will know that cortisone is one of the most potent anti-inflammatory drugs that your body makes. So what happens when you are stressed is you're giving yourself a shot of an anti-inflammatory hormone. An anti-inflammatory hormone that tunes down your immune system's ability to fight disease. If then you're exposed to a flu bug, the bug wins because the immune system is sluggish and less able to fight that bug off. So think of it as a balance. You need your stress response. We all need our stress response, again, whether you're a fruit fly or a salmon or a cat or a rat or a mouse or a human, because that's what gets you out of danger. It gives you focused attention, vigilance, and the ability to flee. But if it goes on too long, you will have a number of different kinds of conditions. You'll have more frequent and more severe viral infections, like the common cold or the flu. You'll have less of a take rate to vaccines. So if you're a chronic caregiver of an Alzheimer's patient, you go out and get a flu shot in order to protect yourself, in order to protect your loved ones. You will be less protected because your immune system isn't able to mount an effective response to that vaccine. If you're exposed to the flu, then you're going to get a more severe or more frequent infections. You're not doing anybody a service by running yourself into the ground and not coping with and finding ways to deal with that stress. And I'll talk about how that can be done. There's also prolonged wound healing in chronic stress. There's also speeding of cancer growth, certain cancers like ovarian cancer, and there's speeding of chromosomal aging. I want to emphasize here that stress, chronic stress, does not cause cancer. Your genes and environmental factors cause cancer. Stress does not cause the flu. The flu bug causes the flu. But stress reduces your ability of your immune system to fight those insults and to repair the tissues. Chromosomal aging is an interesting one, and in fact we were just talking in more detail earlier that the Nobel Prize was awarded last year to an Australian, Elizabeth Blackburn, who was from Sydney and trained, I gather, at Melbourne. I thought of her as an American, but I guess she's your native daughter.
We're claiming her.
You're claiming her. And she discovered the chromosomal aging factor. telomerase. So there's another feature of the stress response that's important in learning how to control stress or cope with stress. And that's a thing that's called the inverted U-shaped curve of the stress response. So I want you to imagine a rainbow here over the stage. If I were at this end, I'd be totally relaxed, I'd be lying down, I'd be asleep, I'd be reading a book, my stress response would not be turned on, the organizers would be stressed, you'd be bored. So I have to turn my stress response on to peak in order to be able to perform at peak, because it's those stress hormones and nerve chemicals that give me the energy and the focused attention to be able to do my job, to talk to you here. The problem occurs if that stress response is turned on too much and I fall over the edge of the rainbow. That's extreme stress, and that's when one would freeze in front of the audience, you choke up, you're unable to do your job. We know something about computers that we do not know about ourselves that helps to deal with this. So there's a researcher in Philadelphia, Gary Aston Jones, who's done these studies in primates that were performing a task, and he put in he was recording from single nerve cells in the part of the brain that controls the adrenaline-like part of the stress response, the locus ceruleus. And when these animals were inattentive and half asleep, there was very little nerve cell. Each of these little blips is a single nerve cell firing. So there was very little firing across the board in this part of the brain. When they were performing at peak, they had a lot of firing of a single nerve cell or just a few nerve cells. When they became stressed or anxious and were no longer performing at peak, were unable to perform, all of the nerve cells in that part of the brain started to fire madly. So we know this about our computers. It's like email spam. If you receive 1 or 2 emails, it's useful. If you receive 10 emails, it's useful. If you get email spam, what happens to your email box? It shuts down. It freezes. It stops. You have to shut down, clear it out, and reboot in order to get yourself back to your email, back to the peak performance. And we need to do that with ourselves as well, to maintain our stress response and our performance at peak. So how do you do this? How do you turn bad stress into good stress? How many of you believe that you can do that? You can turn it. See, it's not 100%. It's interesting. It depends on the audiences I speak to. Well, I'll tell you, you can learn to control your stress response and make it work for you. So I'm going to show you a picture of a profession that is specifically trained to do this. Most of us are not specifically trained to do this, but there are professions that are trained to control their stress response and help make it work for them. This is a picture of an F-14 aircraft, jet fighter flying sideways off the side of an aircraft carrier in the Sea of Japan. It's an American plane. I got this, actually the way I got it is I hate to fly. I get airsick and I'm no longer anxious. I fly a lot. But I was sitting in my seat taking off from Washington to Detroit and was looking for the air sickness bag. And as I was looking, I was getting more and more anxious. And the very kind gentleman to my left handed me his air sickness bag and said, "Don't worry, I'm a pilot." And I said, "Great." It's always a big relief to be sitting next to pilots. We get to 35,000 feet, and he says, "But if anything happened to this 737, I couldn't do anything about it." I said, "Now you tell me." I said, "Why?" And he said, "Well, because I fly F-14s off of aircraft carriers." So we got into this conversation as to whether when he's landing his little plane in the middle of the night, in the middle of a storm on the Sea of Japan, down on the aircraft carrier down below, whether he feels stressed. And he said, "Well, we feel all those things. We feel our heart beating fast and we feel sweaty, but we know that that's a signal that we need to change course. We make our stress response work for us." So it's a good thing to recognize when you're stressed that it's your brain telling you you need to change course. So why is this? Whether you feel stressed or stimulated depends upon the ratio of control to demand that you have over the situation. So if you have a high demand, low control situation, like everybody else in that picture other than the pilot, there's people standing on the bridge of the aircraft carrier. There's 2 little helmets there. You can see one is the pilot, the other is the radar officer, sort of like in Top Gun. And everybody in that picture is stressed except for the pilot. And why is that? Because he's in control. If you're in a high control, high demand situation, you feel stimulated. It's your stress response that's working for you and making you feel excited and positive. So this is the story with the telomerase. When you're chronically stressed, that positive effect of the acute stress response of getting you out of danger gives you those conditions that I described before. And this is just some data in case you don't believe me. Trust me, I'm a scientist, but I thought I'd show you some data. That when you are chronically stressed, the ends of chromosomes, your ends of chromosomes can look 10 to 17 years older than your biological age. If that's not a reason to do something about chronic stress, I don't know what is. So what happens when you're stressed? You're stressed, you're pumping out these stress hormones and nerve chemicals, and what can you do about it? You can do a whole lot of activities, salubrious activities that we now know have a biology, they have a neurobiology, they have an effect on the immune system. That includes meditation, exercise, Tai Chi, yoga. Tai Chi and yoga are combinations of exercise, gentle exercise, and meditation. Prayer is included in this grouping, and the placebo effect, the belief that anything will heal. That's what the placebo effect is. The belief that either seeing a doctor will heal, taking a medication will heal, the belief in a higher power. If you have that belief, there are changes in the brain that occur that actually are quite similar to the changes that occur during meditation and prayer and exercise. And all of these induce a positive state. They cause a reduction in that stress response, and they kick in what's called the relaxation response. Another set of nerves, the vagus nerve, a nerve that wanders, vagus means wanderer, wanders through the heart, the lungs, the liver, the gut, and it's like putting a brake on that stress response. The stress response is putting your foot on the gas and driving 120 miles an hour down the highway, 240 kilometers, I think. That's stressful for me. I have to do mental arithmetic. And the vagus nerve, what happens, you can, in order to slow the car, you can take your foot off the gas, right? And that's what happens when that adrenaline-like and cortisol response diminish. But you can also put your foot on the brake, and that's the vagus nerve. The vagus nerve is working for you by putting your foot on the brake, by slowing the heart, making the heartbeat more variable. This is a good thing. You breathe deeply and slowly. Everybody take a deep breath. Okay, your vagus nerve is now kicking in and working for you. And that gives you that wonderful feeling of feeling relaxed. A lot of these activities like meditation and yoga and exercise and Tai Chi involve deep breathing. And that may be part of why they're beneficial for reducing the stress response and actually boosting the immune system. At the same time, when you're doing these activities, you get endorphins released in the brain, in those parts of the brain that are important in controlling pain. You get dopamine released in the brain, in those parts of the brain that are important in reward and desire. And at the same time, these changes in the brain result in changes in those outflow pathways of nerves and other nerve chemicals and hormones that are beneficial not only for the immune system, boost the immune system, but are also good for the heart. And we know today that when you go to a place where you believe that you will be healed, and a hospital is actually such a place if it's done right, where there are elements... Actually, that's what my new book is about. It's about how you can design place and space to support the emotions and help people heal. I just want to show one slide to show that when you are believing that you're receiving an active drug, these parts of the brain actually do light up that are rich in those endorphins, opioid receptors. We can do brain scans to show that. I'm going to skip through the film here and show you that if you do a simple meditation 3 times a week, 30 minutes of walking a day, and a healthy Mediterranean diet, in 3 months you can increase that enzyme telomerase that Elizabeth Blackburn discovered. And we hope that that will help to repair those ends of chromosomes. The data isn't in yet whether you can stop that aging process, but you certainly will increase that machinery that is available to help repair the damage that comes from chronic stress. Understanding the connection between the brain and the immune system, the many ways in which these two great organ systems can communicate, can help us understand how stress can make you sick, how believing in all these salubrious activities can make you well. It's also important in helping us understand how we can apply these salubrious activities, these complementary and alternative activities, to the armamentarium of medicine. We call it integrative medicine when we add meditation and Tai Chi, yoga, labyrinths, and so on, to help our bodies receive those medications that are such great advances, that have made such great advances in medicine today. And understanding this connection between the brain and the immune system is also important in understanding how the place and space around you can help you heal and can inform hospital design to reduce the negative effects of those stressful hospitals on health. I'm not going to talk about that at all this time today. That was the topic of my other talks in the last day and a half, and it's also the topic of healing spaces, the science of place and well-being. But there's a great deal of data that shows that we can design space and place around to have views of nature, to have reduction in noise, to have social spaces for social support, to have gardens and other kinds of amenities. And what's good for the health of the individual in such spaces, in such hospitals, is good for the bottom line. The extra expenditure up front of about $12 million, it's been calculated to have these features in the environment, can be recouped by those health benefits, about $11 million in the first year. So understanding the brain-immune connection informs all of these factors about how the environment can affect our health. It's very important for health policy, for the use of those salubrious activities in healing, including the arts and healing, and it's very important in understanding how to design hospitals and buildings and schools in a way that is healthy as well as green, and it also informs how the environment can affect health. And we now understand that health is way more than just the absence of disease. And the World Health Organization has for the 21st century, made a statement that, in fact, the environment is very important in health. And we need to consider that when we're making sustainable environments. We want to consider the health of the individual in those environments to reduce stress and enhance healing and prevent illness. So I will stop there. Thank you.